Sounds good. Okay. So I'm going to talk about how we can leverage deep learning and the AI model in the healthcare field. And one of the pressing disease that we have currently is Alzheimer's. And this model is going to scan different MRI images, and it can specify different stage classifications in Alzheimer's. Right. So the agenda goes like this. First, I'm gonna cover a little bit of overview, why we are focusing on Alzheimer's to be specific, how the goal looks like, and then I'll directly jump into the model architecture, how important the data set has to be part of this model, and also how we can evaluate the trained model to make sure the trust and interpretability on that. And then finally, I'll show the demo how we can finally utilize the model and use this overall architecture to live. Okay. So before I start, a quick introduction about me. I'm Reetam Biswas. I work as an associate consultant in Tata Consultancy Service, and it has been over 18 years in the software industry, currently focusing on AI and deep learning and neural network, these areas. All right. So starting with the overall impacts currently we have for Alzheimer's. The recent data says around 55 million affected people who are affected by Alzheimer's disease worldwide. And on top of it, the worst thing is 139 million projected cases would be by 2050 without proper interventions. And if we look at the cost, it's around like 1 trillion USD economic burden over 2030. So we are talking about a like huge impact in terms of specific to the Alzheimer disease here. And the key goal for this model is to, of course, find the resilience, reduce the resilience and the dependency of neurologists in some cases. And also it's gonna provide the screenings and the patients with a higher adherence rate. And especially for the Alzheimer type of diseases, the early detection helps a lot to enable timely intervention and clear planning. And of course, if we are talking about healthcare area, the interpretability is a key thing to measure, and this model can help maintain the trust by GradCam or sharp overlay like of type of um, images. Okay, and also we can further look into the use case like local dashboard can help to track the cases in district level health office. So moving along, when we talk about the healthcare area, the key thing is not the technology; it's more than technology, and it's about building up the gaps between healthcare access or giving family the proper benefit out of it. And the clinical trust is one of the key things here. It shouldn't be a black box to the system. It's more of a building the interpretable AI as a partner. And when we talk about global health equity, we need to make sure it's reachable to everyone with underserved communities across the low resource areas overall globally. And of course, the innovation should go hand in hand, honoring the traditional systems we have right now. Now let's look into the model, how we can architect. So if you look into the picture, the way it works is like we will provide some input images, and it would be the MRI scan images. through wave, or it could be through mobile application that can be fed into our model, and the model will process the image, and finally it can give the different stages of Alzheimer. And the model is built upon a CNN network, but I have tried with different existing models that the efficiency, what I can see, it's more efficiently working on the net B0, efficient net B0. That's one of a CNN model we have, part of PyTorch, Torch Vision. And it is fast, and it's giving almost 99, close to 99% accuracy with perfectly integrated with mobile or web interface. And then the fine tune also, it's quite easy when we are dealing with grayscale MRI dataset. And of course, it is easily integrated with GradCam, confusion matrix, fairness matrix, a lot of different matrix that is available part of this model. And we can go over the detail. So unless, similar to many other models, the data set is one of the key factor here, right? When we talk about MRI scan, of course, the quality of data makes a huge difference when we are trying to train this model. And if you look at these pictures, this is a good example of a good data set. MRI scan images, and bottom I have given some examples of not like good as the above data set that may not give the best result for training the model. And this the graph shows the green dots is performed based on the good quality data set, and it's giving significant improvement up to, let's say, 97.76% for 5,000 images that we trained. And these red dots is not giving comparative results, even if we have a larger data set. And the next thing is it has to be well diversed and well labeled. So when we talk about data set, I have worked on all the public data set that we have right now, and it has to be properly labeled, because we are talking about, when we are talking about Alzheimer's, and we are trying to find out the different classes of Alzheimer's. So this has to be diversely arranged as well as well labeled for each type of classes. And the last thing I wanted to touch upon is the standardized imaging protocol. So when we talk about MRI scan, it can be imaged through a different type of devices that is available, where it is very important to have a standardized image protocols so that we can have a good quality data set. So looking into the data set that I used here is kind of classified by 4 labels. 0 means there is no sign of Alzheimer's. 1 kind of say the mild stage, and 2 measures the moderate stage, and 3 is critical. And this graph shows like how the dataset's distribution looks like. So if you get into the more detail on how the research went, we took around 5,500 MRI images, and which is labeled by 4 classifications. And for 20 epochs, it shows like this. The training loss has significantly decreased with the color kind depicted here, and the validation loss, it's also kind of like dropped significantly. That's a good sign of having a good trained model. And on the other hand, the validation accuracy climbed up eventually for each iterations. Now, when we talk about evaluation, right, we need to make sure the model gives us a reliable outcomes. We have several options to measure whether the prediction has given on the right direction. And a few of them is like we can have a F1 score with overall classification matrix. And we can have the matrix like confusion matrix, and in each cell tells you like how many true level was predicted for certain classes. And then we can also have the visualization like SAP visualization, where in the left side you see the grayscale image of one of the sample MRI scan. And this red dots is giving us the positive contribution to predict the Alzheimer's stages, whereas the blue dots shows the negative contribution, how the model predicted the outcome. And there is another option is to visualize through GradCam. And GradCam is kind of similar as SAP. We have the red, orange areas, which is highly used for a prediction model, whereas the blue or darker images has not so much impacted through the decision making. So let's look into get into more into the technical part of the model. And I'd like to show the notebook that we have and how we can structure the basic model here. So to start with, if you look at the overall steps, it starts like a data processing where we can load the data. And here I segregated the data between a train set and test set. And these things are Parquet file for efficiency. And then this is being loaded into a data frame. And then I distribute it into validation and train to further level. And next step is to apply the transformation. So I have like two different transformation applied for train set as well as test sets. And then once we have the transformation set up, we can convert the data into a dataset format for Torch, Python Torch utility. And then this data set can be fed into our model processing. And as I mentioned, the efficient BNet B0 is giving us quite a good result. And this is where we can assign, load the test data or train data into the model. And then finally, this is where you can see the 30 epochs, for example, is being iterated through each data set where we have the validation phase as well for incremental validation. And this is the data where it's giving like overall accuracy, how it's increased. And finally, once the accuracy looks good, we can save into a file for further evaluation. And once we have that, we can get into the evaluation process, as I was explaining, like SHAP model overview, and we have the confidence scores, and also we can have the plot for different metrics like confusion metrics, and also the GradCam visualization. So this code will be available through GitHub page. So you can, I would encourage you to go over the code and leverage this for different areas. And let me come back to this demo, how it looks like or how we can implement through our interface. So we can either use as a web API, as I said, where we can build a web API. I have used Fast API for this case. So we can build a web API which can be pulled up as a web page. And as you can see, we can choose a file from from the API and then front end, and then this can give you the results with the GradCam image. And other than a simple web page, it can also be leveraged as a mobile app. So I'm going to just show you how it looks in the mobile app, for example. And this is an example of a Flutter app I built, which can be utilized in the same way. We can choose the image from a mobile device, and it can even run offline. Doesn't have to be API. So moving along, maybe just to summarize, the main objective is to build similar model for mostly for the healthcare areas. And this is an example where I covered the Alzheimer disease to classify different classes. And also, as I said, the data source is quite important to make a good trend model where these MRI scans are key factor here. And the method I used is the efficient net B0. It's another part, it's part of one of the CNN model we have. And to add into that, we can utilize the GradCam overlays and SHAP overlays, similar stuffs to make it more reliable. And also the performance can be measured. And this model, it's kind of giving around 99.05% in certain evaluations. And also the uh, front end I used is Fast API as a backend, and the mobile web app is used as a Flutter-based mobile app, which can offer multilingual UI, or it could be work as a offline mode, as I said, and it can also be built for further result dashboard on any extensible to any way. And then the interpretability factor is based on mostly on the GradCam, or it could be SAP images, similar stuffs that can give more confidence, more trust on this prediction model. And finally, the impact is building the technology in the healthcare equity and global. It should address the global benefit. And so let's talk about the future, right? So it's of course can be leveraged for further areas, like it could be brain tumor classification, or it could be used for stroke detection, or maybe some specific cancer subtype identifications. And as I said, like can be extended through other neurological disorders for different image processing. It may not be only MRI scan, it could be CT scan or maybe something else. And also it can be utilized as a multi-model data, right? This is only one model, probably specific to the MRI images, but it can be incorporated with multi-model as well. And to scalability perspective, it can also be added more enhanced interpretability options by maybe GradCam++ or the trust across many different domains may have a different options for the scaling the interpretability. And then another key factor is to how we can integrate, right? This is maybe not only the API, it could be any other platform we used in different hospitals that has to be integrated with, or it could be a telemedicine platform that we can integrate the same thing. And then finally, it has to be keep in mind, like it has to be advanced diagnosis tool for resource limited settings, or it could be a, let's say, offline mode, or it could be a early detection for a specific treatment. There is endless option to an entire healthcare area that we can find out. And I just wanted to add a little bit on the challenges so far. So, of course, the technological challenges are not so much where um, we are trying to implement in a real world. And there are the most use case that we found is the rural area where it's going to be really helpful. And the challenges starts not with the technology, but there are other challenges like how we can get the MRI scan done and how it reacts with different data sets. So there are other bigger challenges as well that we are still working on, and we have option to explore. So with that said, I just wanted to open the floor for